For many years, the question of whether distant planets have ever nurtured enigmatic life has captivated human imagination. In the late 19th and early 20th centuries, the topic of extraterrestrial life on Mars became a sensation. The catalyst was Italian astronomer Giovanni Schiaparelli, who observed faint markings on the surface of Mars in 1877. The varying shades of these markings with the changing seasons led to speculation that they might be the result of canals creating fluctuations in elevation, hinting at the possibility of advanced beings constructing these canals on Mars. However, in 1996, something resembling bacterial fossils was discovered in Antarctica, reigniting discussions about the potential existence of life on Mars. It wasn't until recently, in August of this year, 2023, that an exciting paper published in the journal Nature based on findings from NASA's rovers suggested that Mars might possess conditions conducive to sustaining life. This revelation has ignited hope across various fields, particularly for figures like Elon Musk, who founded SpaceX and expressed the desire to send humans to Mars. Did he make the right bet? Why would it be disastrous for humanity if remnants of past life are discovered on Mars? The vast expanse of the universe holds countless planets that could have evolved life, such as Mars, which was found to have had a natural environment similar to Earth's billions of years ago. However, some scholars warn that if traces of past life are discovered on Mars, it could be devastating news for humanity, perhaps signaling a catastrophic blow in the not-too-distant future. According to the scientific media outlet IFL Science, given the age of the universe, the likelihood of extraterrestrial life is high, potentially including civilizations more advanced than ours. If this is the case, why haven't we made contact yet? Why haven't we found other life forms using probes, similar to what we're doing? In the past, scientists proposed a hypothesis known as the Great Filter Theory. This theory suggests that as life evolves to a certain point, it encounters obstacles referred to as filters, and these filters could arise either in the past or the future. The key focus of this concept is that humanity cannot ascertain whether we have already surpassed the Great Filter to avoid destruction, or if, like other extraterrestrial civilizations, we might have perished before even leaving our home planet. This demise could be due to factors such as warfare or resource depletion. Mars is currently the most likely candidate for extraterrestrial life based on existing technology and discoveries. Nevertheless, some scientists believe that if evidence of past life is found on Mars, given the concept of the Great Filter, this could be devastating news. Oxford philosophy professor Nick Bostrom once pointed out that if simple life is discovered, it suggests that the filter occurred afterward. If multicellular life is found, it further narrows down the time of the Great Filter. He believes that by observing the evolution of life on Earth, we can continue to narrow down the occurrence of the filter. Bostrom warns that if traces of vertebrate life are found on Mars, it would be alarming news because it suggests the Great Filter likely awaits humanity at some point in the future. This means that just before our technology advances enough to venture out of the Milky Way, we could face the possibility of extinction. Such a discovery would be a catastrophic blow. Why is Mars the most likely planet to discover life? There is another piece of evidence for the possibility of life on Mars: water. Although Mars is currently a frigid desert, the dry deltas and riverbanks remind us that liquid water once flowed on its surface. So, where did this water go? For decades, scientists have been trying to answer this question, hoping to understand how Mars became a lifeless wasteland while neighboring Earth retained water, becoming a paradise for life. Recently, a research team composed of geologists and atmospheric scientists has combined observations from Mars with new models to piece together a new view of Mars's history. This suggests that ancient water on the planet might have been trapped in mineral-rich crust and remained there to this day. Previous research indicated that due to solar radiation, Mars's atmosphere was stripped away, leading to the escape of most of its water into space. However, a recent study published in the journal Science on March 17, 2021, revealed a new finding. This study suggests that water on Mars is not only lost through atmospheric escape but also trapped within geological features. The research team presented these findings during the Lunar and Planetary Science Conference held remotely in that year. According to estimates from this new model, depending on the initial water content, anywhere from 30% to 99% of the water could become trapped within minerals in the Martian crust, while the remaining portion escapes into space. If this new model proves correct, Mars's adolescent story might need a rewrite. Currently, all the water thought to be trapped in the Martian crust suggests that the ancient Martian surface had significantly more water than previously estimated by earlier models. Consequently, the early Martian environment might be more conducive to microbial survival than we previously thought. Scientists have been investigating the chemical properties of different aged Martian meteorites and using NASA's Curiosity rover to study ancient rocks and measure the current Martian atmosphere. Through these methods, they have estimated the presence of surface water, whether as ice, liquid, or vapor, at various stages of Mars's history. In its earliest days, Mars might have been completely covered by shallow seas if all the water were in liquid form, ranging from 46 to 244 meters deep. During Mars's earlier years, its atmosphere was thicker, allowing liquid water to exist on its surface due to atmospheric pressure. However, based on observations from NASA's Mars Atmosphere and Volatile Evolution spacecraft, scientists found that Mars likely lost most of its atmosphere, due to solar winds stripping it away, within about 500 million years after its formation. The exact reason for this is still unclear, but the disappearance of the planet's protective magnetic field early on could be a key factor. Regardless of the cause, the loss of atmosphere caused about 90% of Martian surface water to evaporate. The remaining water vapor was broken down by ultraviolet radiation, turning Mars into a water-deprived desert. Discovery on Mars in August 2023. NASA's Curiosity rover on Mars has made a unique discovery in the Martian salt deposits, a pattern of hexagons that evokes the image of seasonally drying basins on Earth. This intriguing finding offers a captivating new clue to understanding the ancient history of Mars. A recent paper published in the journal Nature on August 9 elaborates on this groundbreaking discovery. According to a news release on Eureka Alert, this marks the first fossil evidence of a sustained, periodic, and regular two-season arid climate on Mars. Despite the current barren state of Mars' surface, there is widespread belief that billions of years ago, the planet had numerous rivers and expansive lakes. Since 2012, the Curiosity rover has been exploring the vast Gale crater on Mars, which is believed to have once contained a lake. In the center of this crater stands a nearly 6,000-meter-high mountain composed of sedimentary deposits. William Rapin, a researcher from the French National Center for Scientific Research, CNRS, and the lead author of the study, told Agence France-Presse, "We quickly realized that we were working with deposits from lakes and rivers, but we weren't sure which type of climate they were associated with." In 2021, while ascending the slopes of sedimentary deposits, the Curiosity rover discovered hexagonal patterns in the salt deposits that date back to nearly 4 billion years ago. According to the study published in the journal Nature, these patterns in the soil were identified by the rover's instruments as cracks in drying mud. Rapin explains, when the lakes dried, the mud would crack; when the lakes refilled with water, the cracks would close. With this process repeating numerous times, these cracks formed a hexagonal arrangement. Rapin states that this marks the first definitive evidence of a cyclical climate on Mars. The research team suggests that the regular appearance of rainy and dry seasons, akin to Earth, could provide the necessary conditions for the formation of life. In other words, we are now closer than ever to definitively confirming that Mars experienced both water-rich and arid environments, bringing us closer to answering whether Mars, like Earth, once teemed with life. William Rapin, the principal author from the French Institute of Astrophysics and Planetary Sciences, stated in a NASA statement, "This is the first solid evidence that indicates Mars' ancient climate was so regular and Earth-like with respect to cycling moisture." But perhaps even more importantly, such cycling on the molecular level is helpful, even necessary, for the potential emergence of life. Will humans land on Mars and begin colonization? Mars rovers aren't the only ones securing a ticket to Mars. NASA has set its sights on sending humans to the Red Planet by 2030. Back in late 2017, former President Trump directed NASA to return humans to the Moon before setting sights on Mars. NASA is executing the Artemis program to achieve this objective, aiming to establish a permanent lunar base that would facilitate human missions to Mars. While missions with rovers to Mars have achieved tremendous success over the past decades, sending humans to the planet remains an immense challenge. The path to landing on Mars is riddled with difficulties that have prevented successful human landings thus far. Firstly, the changing distance between Earth and Mars necessitates intricate orbital calculations and optimal launch windows. Additionally, the challenge of safely returning humans from such a great distance in space with current technology escalates mission costs and risks dramatically. Secondly, Mars presents a harsh environment with extreme cold and a thin atmosphere, posing significant challenges to human survival and health that require solutions to numerous technological and medical issues. Lastly, the composition of Mars soil remains uncertain, and potentially unfavorable microorganisms may exist, posing a risk of biochemical crisis. Overall, the current technological level and knowledge of humans render Mars landing an exceptionally challenging goal, requiring breakthroughs in multiple technical, biological, and environmental aspects. Despite these challenges, the human spirit of exploration remains undeterred. The United States has been a pioneer in Mars exploration, and though NASA has faced funding challenges, entrepreneur Elon Musk's Mars colonization plans have garnered widespread attention. Despite the multitude of challenges including technology, funding, and environment, humanity's desire for and determination in exploring Mars remain unwavering. Will Mars be humanity's next inhabited planet? Perhaps the coming years will shed light on this question.